Hello guys, welcome to the one more lecture on differential equations of higher order. So in this lecture also I'm going to continue with few more examples related to the differential equations of higher order. So we'll see the first example. The problem is like this: d square y by dx square plus 4y is equal to x square plus cos 2x plus 2 power minus x. So here we can observe in the RHS part, it contains the combination of all the types. The first one is a polynomial equation, second one is the trigonometry, and third one it can be converted in terms of exponential. So now we'll solve one by one. So first I'm going to find the complementary function. So to find the complementary function, we should have the auxiliary equation. So make the auxiliary equation by replacing d is equal to m. So I will get m square plus 4 is equal to 0. On simplifying m square plus 4 is equal to 0, I will get the roots like m is equal to plus or minus 2i. So since it is a complex roots with a real part equal to 0, the complementary function will be yc is equal to c1 cos 2x plus c2 sin 2x. So now I want to estimate yp. So take each term separately. So x square by d square plus 4 one equation, cos 2x by d square plus 4 one equation, and plus 2 power minus x by d square plus 4 one equation. So I'm going to name it as p1 plus p2 plus p3. So where p1 p2 p3 is nothing but a particular integral. So now we'll solve one by one. So p1 is x square by d square plus 4. Since it is a polynomial, we have to solve this one by using long division method. So take the x terms in the inside the bracket in the decreasing order, and take the operator equation, I mean d equation, outside the bracket in the increasing order. So to find the first root, take the first element of the polynomial equation divided by the first element of the operator equation. So I will get x squared by 4 as my first root. So now multiplying entire operator equation with x squared by 4, I will get x squared there. And again applying d square with x square by 4. So d square in the sense differentiating x square by 4 twice with respect to x. So on differentiating x square by 4, I will get 1 by 2. So it will become what? On cancelling the equation, minus, so x square gets cancelled, minus 1 by 2 I will get it. So minus 1 by 2. Now to find the next root, I am taking the first element of the equation minus 1 by 2. So only minus 1 by 2 is there. I am taking minus 1 by 2 divided by the first element of the operator equation, that is 4. So it will become minus 1 by 8. So I can take the root as minus 1 by 8 there. So now multiplying entire equation with minus 1 by 8. So 4 into minus 1 by 8 will be minus 1 by 2. D into minus 1 by 8 will be 0. So I can get 0 here only. So we can stop the iteration now. So the particular integral will be x power 4. So x square by 4 minus 1 by 8 for p1. And I can take 1 by 8 common factor. So I will get p1 like p1 is equal to 1 by 8 2x square minus 1. So now we will see how to solve p2. So p2 contains trigonometry function, that is cos 2x by d square plus 4. So according to type 2, we have to replace only d square terms with minus a square. So here x coefficient is 2. So we have to replace d square by minus 2 square, that is minus 4. So on replacing d square by minus 4, the denominator will become 0. So once the denominator is 0, we have to multiply x for the numerator and differentiate the denominator. So on differentiating the denominator, I will get d square will be 2d, constant will become 0. So I got the p2 like x cos 2x by 2d. So since here directly we can't simplify the d value, I'm going to multiply and divide with d. So I will get x into d cos 2x divided by 2d square, I will get it. So to make the d values d square, I am multiplying and dividing with d value. So differentiating sin 2x with respect to x, I will get 2 sin 2x. So 2 gets cancelled, and replacing d square by minus 4, I'll get minus 4 there. So in the numerator we'll get minus sin 2x. So negative gets cancelled, I'll get x sin 2x divided by 4. So this is the value for p2. So p3 will be 2 power minus x. So here we can't simplify directly. I'm going to convert this 2 power minus x as e power log minus 2 whole power x, or we can make like like e power 1 by log 2 x we can write. So since the function is e2 power minus x, it will become e power 1 by log 2 into x. I can write it here. So on replacing the constant d value here, I'll get the p3 as 2 power minus x divided by 1 by log 2 whole square plus 4. So now to make yp, add all p1 plus p2 plus p3 values, we'll get the yp value. So combine yc with yp to get the complete solution. So y will be equal to combining both yc and yp, I will get c1 cos x, c2 sin 2x plus 1 by 8, 2x square minus 1 plus x sin 2x by 4 plus 2 power minus x by log 2 whole square plus 4. So this is the solution for the given differential equation. So we'll see one more example on the differential equations. The problem is like this. Solve d square plus 3d plus 2 into y is equal to e power x by method of variation of parameter. So here the first step is, already we know that we have to find the complementary function. So to find the complementary function, make the auxiliary equation. So m square plus 3m plus 2 is equal to 0. I will get it. So multiplying means I should get 2, adding means I should get 3. So I can take 2 plus 1. So m square plus 2m plus 1 plus 2 is equal to 0. I can write it. So on simplifying the equation, I will get m is equal to minus 1 minus 2. So since here roots are real and distinct, the complementary function will be yc is equal to c1 e power minus x plus c2 e power minus 2x. I will get it. So now y is equal to, I can write like a into e power minus 2x plus b into e power minus 2x with the complement. This is a complete solution. So here I'm going to assume the complete solution based on the obtained complementary function. So I'm going to assume like this: y is equal to a e power minus x plus b e power minus 2x. So in this regard, we have to find the values of a and b. So where this a and b are the functions of x. So now the first step is, now we have to find the Wronskian. So to find the Wronskian, we should have y1 dash and y2 dash. So from the complementary function, choose y1 and y2. So y1 will be e power minus x, y2 will be e power minus 2x. So differentiating y1 and y2 with respect to x, I will get y1 dash minus e power minus x, y2 dash will be minus 2 e power minus 2x. I will get it. So upon replacing all these values in the Wronskian w, I'll get the Wronskian like y1 y2 dash minus y2 y2 dash y1 dash. On replacing all the values, I will get the Wronskian like minus e power minus 3x, and the function pi of x is given by e power x. So now we have to find the values of a and b by using the formula a dash b dash. So a dash formula is minus y2 pi of x by Wronskian w, b dash is y1 pi of x by w. So a dash is equal to e power minus of e power minus 2x, e power x by minus of e power minus 3x. B dash is equal to e power minus x, e power x divided by minus of e power minus 3x. Upon simplifying the equation, I will get a dash is equal to, so I can cancel e power 2x with e power 3x. I can shift this e power 3x to numerator. So I will get e power x into e power x. B dash is the same thing only. On shifting this e power minus 3x to numerator, I will get minus of e power 2x, e power x. So now I want to find a and b. So to find a and b, integrating a dash and b dash with respect to x. So I'll get a is equal to integration of e power x dx plus k1. B is equal to minus of integration of e power 2x e power x dx plus k2. So since it is highly complicated to simplify e power x, I'm going to replace e power x is equal to some other variable t. So upon replacing e power x is equal to t, e power x dx will be dt. So on differentiating both sides, I will get e power x dx is equal to d. So in both the equations, I can replace e power x as t value, e power x dx as dt value. So if I replace this value in the a and b equation, I will get a is equal to integration of e power t dt plus k1. B is equal to minus of integration of t e power t dt plus k2. So on solving a equation, so integrating e power t with respect to t, I will get a is equal to e power t plus k1. So again replacing by the value of t, I will get a is equal to e power x plus k1. So on simplifying b by using product rule, keeping t as u, exponential as v, apply the integration by parts by here. So I'll get b is equal to minus t times of e power t minus e power t plus k2, or on replacing t is equal to e power x, again I will get e power x is equal to 1 minus e power x. Upon replacing t is equal to e power x plus k2. So now replace this a and b in the assumed complete solution. Y is equal to a e power x plus b e power minus 2x. We'll get y is equal to e power x plus k1 e power minus x plus e power x 1 minus e power x plus k2 e power minus 2x. So on simplifying the equation, we'll get y is equal to k1 e power minus x plus k2 e power minus x. So here we can cancel that e power x term into e power minus x with e power x term into e power x with e power minus 2x. So I'll get only e power minus 2x with e power x. So this is the solution for the given differential equations by using the variation of parameters. Thank you.